Okay, so for problem 13, it is asking, find the tension T in each cable and the magnitude and direction of the force exerted on the strut by the pivot in each of the arrangements. In each case, let W be the weight of the suspended crate full of priceless art objects. The strut is uniform and also has a weight W. Start each case with a free body diagram of the strut. So here's the diagram. Right there. So part A, solve for the torques of the box on the strut and for the torque for the strut on the strut. So the I'm gonna write it down here and then show you guys. So the torque of the box equals R times W times sine. It's just the magnitude of torque, and the theta for this one is 60 degrees. And then for the box, it'll equal and then for the strut, it'll equal R halves times W times sine of 60 . Okay, here it is. Can you see that? I hope so. So the sum of the box and the strut torques equal the torque for the support cable. So I'm going to solve for the force of the support cable. The force equals the tension. So I will be doing and then solving some more. So the force of the cable equals 2.598 W. Now I'm going to use the distance formula to solve for the magnitude of the force exerted by the pivot. So I'm going to be using these components and doing the distance formula on them. So the force of the pivot is 3.28. Can you see that? And then I'm going to draw a triangle to visualize the system. So I'm going to use arcsine to solve for the angle of the pivot, and then the angle is above the strut, so I'm going to subtract 90 to solve for the angle of the pivot's force with respect to the x-axis. So arcsine of 2.6 over 3.28, what we just found, of those numbers equals 52.4 degrees. So like I said, I'm going to subtract 90, and that'll equal 37.6. So our angle of the pivot is 37.6 degrees. That was part A. So for part B, I'm going to solve for the torque of the box on the strut, the box on the strut, and the strut on the strut, just like I did for part A. So will equal R times W times sine of 45, which is 0.707. This is a W. And then for the strut, it will be R halves times W times sine of 45, which will just equal 0.354. And then I'm going to do the sum of the boxes as I did before, solve for the force of the support cable, and the force equals the tension again. So, like I did before, I'm going to do the same calculations, just with different numbers. Sine of 15 degrees. So the force of the cable will equal 4.1. Now I'm going to solve for the force components of the support cable. So sine of 30 degrees will equal the Fy component minus the cable over 4.1, and then cosine of 30 degrees will equal the F of x minus the cable over 4.1. So F of y minus the cable, like I said, is sine of 30 degrees of that. So it'll be equal to 2.05 W. And then Fx minus cable, just solving for it, will equal 3.55 W. So I'm going to add all the forces together to solve for the pivot point, and then use arctangent to solve for the angle of the pivot point, and then use the distance rule for the magnitude of the pivot force. So F of y will equal 4.05 as we found before. F of x will equal 3.55 like we found before, and then I'm going to do the arctangent of F of y over F of x, which will equal 48.8 degrees, and then do the distance formula, or sorry, the magnitude of this and this, and that'll equal 5.39. So as a summary, part A, the let me see. Okay, so T of the cable is 2.598, and then force of the pivot is 3.28, and then the angle of the pivot is 37.6 degrees. That was for part A. And then for part B, T of the cable was 4.1, F of the pivot was 5.39, and then the angle of the pivot was 48.8 degrees for part